Hello, everyone. My name is Lisa Gulker. I am a business leader with Cerner Corporation, and I'm thrilled to be able to talk with you about some great work we're doing in collaboration with AWS and our health system operations and real-time health system group. I am a nurse by background. I'm a nurse practitioner. I've spent most of my career in health system operations, which means, and in informatics, clinical informatics. So my job has always been to marry clinical practice, running health systems, and informatics and other clinical and information technology systems to help everything move according to the way we want it. And so in the last couple of years that I've been with Cerner, I've been involved in some great work around bringing real-time visualizations, advanced analytics through our platforms, through our collaboration with AWS in order to make some of that work a reality and scale very quickly and help health systems. And that's becoming even more relevant today than we expected in light of what's going on with some of our response to a global pandemic. And we'll talk about that too. So the title of the talk is Enabling a Real-Time Health System. We have been really deeply engaged with our own data science team at Cerner, with data scientists, data architects, systems engineers in both the Cerner and AWS side, and have enabled this work, as I said. So what is a real-time health system? This has been an interesting topic. It's really only become a market concept in informatics, in IT, and in health system leadership over the last couple of years. We're seeing a lot of research in the literature of Gartner when it looks market-facing and says, what's the best way for health systems to use technology in order to enable the best possible experience, meaning clinical care, but also operational and customer experience for patients, families, and communities. And so that's been what we've sort of developed the idea of a real-time health system around. We use that term to talk about a next generation health system that is able to act on real-time information to achieve predictable excellence in clinical, financial, and operational outcomes, meaning patients get the best possible care they can when they're involved to seek care at the health system, that we provide a good operational experience, meaning they don't have to wait for services. If a physician or other clinician needs to perform care, deliver care, that all of the resources needed to deliver that care happen on time in an efficient manner. And then from a financial perspective, that's really about stewardship for us. We are stewards of healthcare resources. We're privileged to be able to serve patients in the capacity that we can. And so we want to preserve those resources and use them for the good of all of the communities and large populations so that those resources are available for everyone. So that's what we mean. When you see this diagram, you'll see there's a focus on both the patient as someone who's seeking healthcare services, but they're a consumer as well. And we want to make sure that we're bringing in real-time contextual experiences into that for both the patients and the clinicians and other support services that surround the patient and enable them digitally to do their very best work. These are a couple of quotes we use quite often when we talk to clients about what does it mean to be a real-time health system, why is it important. Situational awareness is a term you'll hear in almost all of the literature around being a real-time health system. That means that there is a very carefully curated data set that needs to be brought to bear in real time for people in healthcare to do their best work and for the clinicians and patients, as I said, to get their best experience. And so in order to do that, it often involves lots of complex logistics in order to make a very complex system work. We figured it out in many industries. We haven't quite gotten there in healthcare. If any of you have ever waited for care in an emergency department, I think you'll know what I mean. You often wait too long, even for things that seem simple. Sometimes that's because patients who are much sicker need the attention of the care team and the resources more quickly than you do. but sometimes it's just that things don't coordinate the way that we'd like them to. It is a three-dimensional chessboard, many layers to the chessboard, and all of the pieces have to move in the right way in order to get the resources to the patient in the way that it's ordered by the care team. And so that's really complex, and we really do need data science, applied data science at scale, and achieving those things through machine learning and artificial intelligence really can probably get us to the next level. So this is just a visualization to show you, we're going to talk about some concrete examples of how we've used the tools in our, what we are calling our real-time health system platforms, our command center dashboards, in order to manage that supply and demand. So at its very simplest form, patients present for service. Physician orders care, meaning in the hospital space in particular, which is a use case we'll talk about today, there's a decision made whether the patient can go back to where they came from or whether they need to stay. Once that medical decision is made, then we have to bring resources to the patient. And as I said, a very complex operational system. There's a care team with lots of different roles, lots of different levels of experience, and we want them to practice at the top of their license so that they can bring all of their skill and their wisdom to care for the patients. There are beds, not just beds to lie in, but actual physical spaces in rooms so that the patients can be moved from one place to another, as well as specialized equipment that the patient may need, as well as a level of care. Are they sick enough for a critical care unit? Can they go to a regular medical surgical unit? These are all very complex things that are prescribed as soon as the patient can't go back to where they came from, whether it be home or a skilled nursing facility or somewhere else in the community, another hospital that doesn't have the specialized care that a patient needs. And the health system's job is to bring all of those resources to the patient in a very smooth and efficient way so that the patient gets the best, as I said, best clinical outcome, but also a very good experience. No patient no person who isn't feeling well doesn't want to wait for the care that they need. So why is this so hard? Because this has been a very difficult challenge through my entire career. And I really do feel like we're getting to a place where we have the right technology that when combined with human beings who want to do their best work, we can actually solve this problem of operational and clinical inefficiency. We talked about some of these challenges at the beginning a few minutes ago, which is how can we be the best possible stewardship of resources that are needed, especially again in light of the pandemic response we're working through right now in early 2020. There are increasing cost and revenue pressures no matter where globally health systems live and work. Whether you're a payment system like the United States and your payment system in another part of the world, there are increasing pressures to perform better, but at a reduced cost. We want to avoid variations in care and clinical outcomes. We know there's expectations with artificial intelligence and machine learning that we make processes better. And so there's an expectation on the health system side that we who work in technology actually deliver on that. And then patients are becoming consumers more and more. We've all heard about this, especially as they take on more of the burden of paying for care. They expect a certain level of service in exchange for that. It's very difficult to recruit and retain clinicians. And so if their experience isn't good, then you tend not to retain or recruit clinicians. That's also a challenge. Patients are sicker, patients are older, and on top of all of this, health systems often want to grow. They want to grow in their mission to deliver health services to a community. And in order to do that, there's so much friction in that list I just presented to you that it's very often difficult for them to pivot and say, and in the meantime, I also want to grow and offer more. And so again, there's a lot of uncertainty that's occurring right now in healthcare. So we're seeing this weird dichotomy of health systems that are burdened with response to a novel disease process that we don't know very much about, that the data and the science change every day. And then we're also seeing health systems who didn't see as much of that impact from a novel disease, who are also laying off or furloughing parts of their healthcare system workforce in order to make up for the fact that they're no longer doing non-elective, non-urgent care for non-COVID-19 patients. So how do we then answer this and pivot very quickly with real-time data that's helpful in order for them to function in this time of transformation in healthcare and a lot of uncertainty every day? Health systems want to make their decisions based on data. They're taking care of other human beings, and they feel very strongly that they have to do that well. And in order to do that well, they really need data, and they need data in real time. What happened yesterday is not the best source of data to decide necessarily on what you should be doing today, especially in a very fluid and evolving situation. So what does the next generation of care look like? One, you have to connect all of your data networks. We work very hard with all of the tools that are brought to us and the services brought to us in the cloud architecture with AWS in order to connect lots of data sources in a meaningful way, in a very nimble and agile way. We want to bring analytics into workflow where it matters, where it's not going to distract, but only augment decision making. And communication of those analytics and the right workflow also really matter. Then we can begin to bring in predictions and say, not only can I tell you what's happening right now, but I'm going to give you a view beyond the windshield out into the future. The windshield's really clear. You can see what's true now, but you can also see what's coming. So there's a little bit of looking in the rearview mirror. There's a lot of understanding what's happening in the windshield right now to make a decision, and then look forward to see if that informs the decision as well. So we really need to empower teams with predictions, and then transform, really propel that excellence. Then you have a team where data is democratized, everybody can see it, it's not held on a piece of paper or an Excel worksheet somewhere, and folks are really working hard based off the same real-time analytics. Then I do believe will make a big difference and help suggest to the decision makers what to do in their immediate workflow so that the rest of the system works very well. Okay, so what is the analytics paradigm that we wanted to use? We really did want to look at being proactive in our analytics instead of retrospective, or instead of reactive. Descriptive and diagnostic analytics are very important. So what happened yesterday and why did it happen should inform how teams get better, but healthcare performance management can't stay in the reactive paradigm of analytics. We've got to move into predictive, prescriptive, and planning analytics using the tools that we have from data science, in machine learning, in artificial intelligence in order to do a better job. So what does operationally aware healthcare look like? We focus in 3 main venues or areas of work in order to make that happen better. Staff optimization or workforce optimization. We objectively look at the workloads that are being experienced in each of the clinical areas in a health system. We want to be able to provide mobile scheduling, satisfaction with staff, controlling their work environment a bit. Healthcare is the largest labor sector for worldwide, and it just happened at the end of last year and is going to continue. It's a very large part of the service industry, and so we know that's an important investment for health systems, and we want to see a return on investment on staff. Automated throughput, meaning we're going to move patients through the healthcare system in an efficient way. And then centralized operations doesn't necessarily mean that we've got a big dark room with lots of analytics on a wall and people with headsets making decisions. Sometimes that's what makes sense, but what we mean by centralized operations at the core is we can anticipate all of the demand that a health system is going to be asked to answer make sure they have the right resource to supplies in order to answer that demand, and that anyone who's making centralized decisions, even if it's centered around a person, they have all the data they need in a centralized way to make a good decision. And so we do want to make sure we bring in that centralized decision making so that there's everybody on the team knows exactly what kinds of decisions they're being asked and to make, and have the right data to do so. So what does that take? We know it does take a lot of people at process change and as I always make sure we are leaning on informatics and transformation teams, because they're the ones who know that it takes a lot to take data and move it in a paradigm into solving human problems, and that often does take transformation, and informatics professionals are often very well trained in the ability to do that. But we do need some technical foundation to do this. We need a real-time data strategy. So what is the real-time architecture that you have put in place to ingest a curated data set that you know is needed for predictions and to present the data in real time, and that you stream that and have a very purposeful LPR, that means longitudinal patient record, in order to do that. Then we've set up something we call CMLE, and that means Cerner Machine Learning Ecosystem. That's all in AWS tooling. I am not the person to tell you exactly what all those tools are. Luckily, our data science operations team, our engineers, in concert with AWS partners, have really done a great job of putting that machine learning environment together. What I do know is, using that tool set, they have produced for us some very robust predictions around what is the volume I'm going to see in an emergency department in a hospital? What is the expected length of stay in the emergency department, both at a patient and an aggregate level? That is our data science factory. That's the way I explain it to health system leaders. That is a place where we can generate predictions and display them to you in the next step, which is advanced visualizations and notifications. That's the front end user interface, where we can see the data presented both in real time and a predictive fashion. We can trigger alerts and notifications off of those to tell the right folks who might not be in front of a device all the time. But that data science factory is really important, because we know what they're doing with that is taking in these kinds of data sets. These are the 4 major data sets that we take into the CMLE and into our platform that we call CareAware. Individual patient history influences our algorithm and our predictive outputs. The current health system state, a patient's throughput or their length of stay is going to be longer if everywhere else in the health system is busy, as opposed to when things are quiet. That's kind of a simple example. Situational data. So APIs to weather systems, air quality makes a big difference in cities. If you can imagine precipitation, a snowstorm in Atlanta, Georgia, or another warm climate makes a big difference in what happens in their emergency department, as opposed to Chicago or Detroit or somewhere in the state of Maine. Or in Canada, they expect snow and are prepared for it. Southern climates generally aren't. So that will influence volumes, length of stay, staffing levels, all sorts of things about a health system and about the way they work. And then current encounter means, why is a patient coming in today? What is the reason that they're here? What's their chief complaint? It looks at lab results, vital signs, other things that are aggregated in the medical record as the patient goes through their stay, and predictions are aggregated and updated in near real time in order for us to look at how things are working in the hospital. So what's the need? We do have to deliver machine learning at scale. There are lots of use cases I just presented, and we'll go through a few more when we look at the dashboards that are the wonderful results of all of this work from our data science and engineering teams. There's operational, financial, and clinical use cases. We're going to mostly talk about operational use cases today. And then, do we have the right pipelines there for training the machine learning algorithms and serving up the right data streams and then again producing the output. And as well as that, and then the second part is the end-to-end machine learning. So I know that that data science team, as I presented them the use cases, they've gone and worked within the data structures to make sure the data is managed, that they have the right data set to work from in order to train algorithms, developing new models, hosting and deploying those models in the CMLE, and then monitoring their performance for drift. So what we say to clients that in health systems that we've used our algorithms with is, we will, in the Cerner Machine Learning Ecosystem, monitor the performance of the models if they begin to drift and they're no longer useful for predicting the volume of patients that will be coming through an emergency department in a health system. Then we will make corrections, make adjustments in the model, and then get back to the performance level that we expect. Then centralized access to data required for machine learning. That's another need for CMLE. And so we've, in our work with AWS, we began to construct our team, our data science team, around these three things that are needed. And so here's the life cycle that my data science partners at Cerner have put together, and I know that they've been consulting with their peers in AWS as well as they began to put the machine learning ecosystem together. So decide on the scope. You can see the roles there. There's data scientist, data analyst, a strategist who helps interpret the use case I bring from when the market, meaning the health systems, tell me what they need to run their hospitals in a more efficient way, in a more effective way. Strategist helps document that use case. Obviously, project managers and data engineers to set up the actual tooling that the platform needs. So you can see there's quite a bit, subject matter experts, terminologists, especially depending on what the data source is. We need folks to help us dig in and get the right data structure. So we spent a lot of time early on defining the problem, looking at the literature around patient throughput in particular, and then getting client and subject matter expert input. Then prepping the data took quite a long time at the outset. Now that we're scaling, they've got the process down and they're going very quickly because there's an enormous demand for this in the market right now, and it's very useful for health systems to use. They get the model, they deploy it, they deploy that code into CMLE, integrating that into the workflow. We have defined KPIs around number of patients waiting for a level of care, number of patients they're able to process throughout a day in a health system. It truly is a logistics equation and problem that we have to solve. So you can imagine that you can balance demands for services or the right people showing up for care in the right venue. So not everybody belongs in an emergency department. They could use urgent care. They could use their physician office, for example. The other side of the equation is out in the hospital itself, are they moving patients through onto the next venue of care? If they're ready to go home, if they're ready to go to a lower level of care, are they being discharged? It's really moving patients throughout the system very effectively. So that's why we need machine learning predictions to help us make decisions in every venue of the hospital, not just the front door. It's needed in the hospital itself, in the surgical suite, all sorts of places. And again, it just becomes a cycle. So here's what we're trying to get to. What we're trying to get to is we take simple data, so to speak, data we generate all the time through our use of systems and healthcare. We begin to make some predictions around, again, length of stay, what do seasonal or historical volumes look like, kinds of patients we see depending on the time of year and the time of day or even the day of the week, how many patients are waiting throughout the hospital to be moved. Then as we take that and put that all together, if you're a very important team member in healthcare whose job it is to receive a request to move a patient from one place to another, the machine learning, the data science at scale is what can order the right queue of patients who should be moved first based on their clinical condition, based on the beds available, because that move, again, just like a chess game, only remember it's stacked in 3 dimensions, that all of those moves influence the ability for us to move other patients. And so that's a lot of cognitive work for one human being to do, to decide either I'm going to do things from the time I get a request and just work through my queue, or can data science at scale help me to order my work so that I am more efficient and I produce a better outcome for a patient. And then when you do that patient by patient by patient, it aggregates into a better experience and a much better functioning health system. So that's what we're looking to do, is we're looking to take notifications to environmental services team members whose job it is to make sure they disinfect areas and make it ready for a patient to be cared for. They know how to order their work. Transporters know how to order their work. Who should a radiology department test first? Where should a laboratory technician go first to draw a blood sample? Who should a physician see first? I've got a list of 15 patients as a nurse practitioner. I know that I may not know which ones I should go see first, because I'm not aware of who's waiting in the emergency department. But all things being equal, if a patient's not very sick, I would like to go see the patient first who I can discharge, because at that level of care, there's another patient waiting in the emergency department. So those are the kinds of things that data science at scale can do in healthcare at an individual team member level, so that we're all working in the best way to contribute to opening up more capacity so that more patients can actually get to the care that they need. So this is our command center concept. We always start at the core. We've been talking a lot about patient flow because it's at the bottom of the hierarchy of needs. Patients present for service, they need a bed, they need a care team, and they need equipment in order to answer for their needs. That is at the core of what we do in healthcare. After that, we can begin to layer in some very important work around managing care in, again, a very complex environment that has been used to managing performance based on retrospective data. Again, the whole point of this data science and the machine learning at scale is that we're now bringing real-time data into a workflow so that people can do their best work on behalf of patients. So that means that now we can begin to centralize the work of care managers. Their job is to work on social needs of a patient and a family so that they have a safe environment to be cared for in after the hospital. They can order their work so that they deal with, and we could perhaps risk stratify patients and say that more administrative tasks can go to a centralized area for care management, and that the care managers out on the floors can do the more complex planning with patients and families, but offload the administrative things. The way that we do that is risk stratify. How do we get great risk stratification and great guidance? Data science at scale. Managing transfers that don't come from the emergency department or don't come from a surgical area, but they're coming from the community. How do I manage that ambulance and life flight traffic? Again, data science at scale can inform that. Clinical surveillance for clinical conditions, early detection. That's important to bring better use of resources. If you catch patients who might be deteriorating early, they don't stay in the hospital as long, they have a better outcome. Every one of these has a data science at scale story. It is our intention now to use this Cerner Machine Learning Ecosystem to inform every one of these things that really become the hub of excellence in centralized operational care. This is, I'm so proud to present to you our Cerner Command Center dashboard. You'll see that we're just starting to bring predictions face forward in this. This is the output, that advanced visualization I showed you a few slides ago. You can see at the top, at a glance, you can see how busy this particular hospital is. They have 234 patients who have heads in the beds. They're expecting 12 admissions. They have confirmed discharges. It does the math and shows you that they're increasing their census. So, and we can change colors to help visually cue somebody who's accountable for bed management, that they've got to manage discharges and admissions in a more coordinated way. We have 4, 8, and 12-hour predictions face up for predicted census. You're seeing as the day goes on, this hospital will get more busy. It shows high-level KPIs for environmental services and transportation. Are they turning around their work on the team to make beds and spaces ready? Then you can see from left to right, the emergency department status. They're very busy. How long patients are waiting. They have 9 patients in the waiting room. They have 3 patients waiting for a bed. Surgery is the same, 3 patients waiting for a bed. And then you can see critical by level of care and by individual patient units, how full is the hospital and who is the most full. That very last panel on the right-hand side gives the team a glance of patients who have either exceeded, met, or are approaching their anticipated date of discharge. That's that part I talked to you earlier about managing length of stay in the hospital. Who should have been discharged and has not yet, and why? What are the barriers to getting to them? So this is a dashboard that lives on top of that CMLE I talked to you about, in our data ingestion, and then again, the advanced visualization platform we call CareAware. What's great about the dashboard is it's really truly near real time. It's all automated. There's no manual data entry required for this data. And the other great thing is that now everybody has a situational awareness on what's going on. If I had this tool 10 years ago when I was running a hospital, it would have made my job a lot easier. Here's an example of how then we take the predictions into a specific venue of care. Right now, we have in our emergency department information system called FirstNet, a real-time ED dashboard to give a situational awareness to real time. Now, based on this data science at scale adventure we're on, we can take and fold in predictions. So now we've taken our real-time data, which is, you see a length of stay of 3 hours and 52 minutes, for example, in the upper left-hand corner. Now we can say, and here's what we predict it will look like based on the algorithms that our data science team has produced. In 4 hours, you've scaled down and your waiting time is less. So now we're introducing real-time and predictive data into a workflow that did not have it before. What's even great, even more exciting about this is then you can do some drill-ins. Now, if you look at this view, you see that there's a rolling 24-hour view of predicted ED census. Time 0 is in the center. You have the situational awareness of your rear view mirror, both a historical line to represent what you typically see on this day of the week, on this month of the year, and how census was and volume was. And then when you look forward, you can see predictions of what it will look like, and do the predictions vary significantly from your historical performance. And then the other thing you can see is individual patient data, their predicted length of stay, their predicted disposition, meaning we're predicting the patient will go home, we're predicting the patient needs a bed in the ICU, predicting the patient needs a behavioral health bed, whatever it is. The reason that's important is now we can truly begin to inform individual healthcare team members' work. If I know, and if my role in the emergency department is a manager of the ED, and my job is to round on patients and families and make sure that they're getting what they need, as the rest of the team is taking care of the clinical parts of what's going on with the patient, then I will perhaps round on a patient who has to wait a long time for a bed more frequently, make sure they get a meal ordered, make sure they perhaps are moved from a stretcher to a bed. All of that is a better experience as they wait for their bed. And then here's another example of what pending admissions look like and what kind of level of care they will need. So a few words about the new normal for healthcare. The data and the science change every day and sometimes several times a day. As a clinician, I'm reading in the evening to keep up with all the things I need to understand in order to take care of patients in acute care today. But I also know that operationally, if I were running a hospital again, I would need to understand much more about the public health situation in my community than I did before, because that's going to inform how I decide to bring on more care for patients who are non-COVID-19 as opposed to who are COVID-19 and need COVID-19 care. I have to manage 2 patient populations now. That is my new normal. The other part of the known and known we have, though, is that if we didn't realize it before, we know now more than ever that healthcare resources are critical national infrastructure. They're critical global infrastructure. We need the situational awareness at all times of all of the resources that are available to respond to an emergency or a disaster. So how many beds at what level of care we have available, mechanical ventilators, healthcare supplies, personal protective equipment, and more importantly, the clinical workforce themselves, their skill set, their capabilities, their ability to be mobile. All of that now is something that we've realized as people, as everyone across the globe realizes now, you have to understand that and be able to understand it very quickly. Not much can do that other than very robust, agile, cloud-based tool sets, environments that can bring you that kind of data aggregation and help you flex to understand what's the real-time data I need to know now. So we are going to have to address two-pronged operations in most healthcare delivery systems. Every aspect of that supply-demand equation has changed. I do have to make sure that now if I'm running a health system, I maintain my capability to respond to an increase in disease activity in my community or be able to donate that to another community who needs it. And a very clear line of sight into public health interventions and results is crucial, of course. Thank you all so much for your time and attention. I hope you're as excited about this topic as I am. And we've got some great things in the future. So thanks again for attending.